Thank you everybody for joining us today. This is our webinar, Resolving Critical Ventilation Issues. We have with us today Lou, Marvin, and Vi, and they are going to be talking us through their experiences managing ventilation issue resolution during COVID, how that's changed and affected everything. You know, with there being a viral respiratory pandemic going on right now, ventilation systems become a bit more important, and when they go down or aren't working properly as you'd expect, that impact can be a lot greater. So I'd like to have our panelists just go through, quickly introduce themselves, provide some background on their experience and also what their job sort of looks like managing COVID before we jump into the questions. So Lou, would you like to kick us off?
Sure, thank you, Matt. Hello, everybody. My name is Lou DiBerardinis. I'm the director of the Environment, Health and Safety Office at MIT. That's an office of about 70 people, professionals in a variety of areas from radiation, biosafety, chemical, fire safety, environmental management, etc. My background is I'm essentially an industrial hygienist by training and have, I hate to say this, but about over 40 years experience mostly in higher education, looking at health and safety issues.
Great. And Marvin, would you like to go next?
Hi, everyone. My name is Marvin Kirschenbaum. I'm a mechanical engineer. My background basically has varied from facility engineering and operations to consulting for a little while, and then back into facility operations. And most of my career in operations was spent at Argonne National Laboratory at the Advanced Photon Source, which is a 17 building X-ray, synchrotron X-ray radiation facility. It's one of the 3 largest in the world. And I was part of the design team and then went into operations and maintenance and tenant work and building out the rest of the facility over the years. So my background is basically in mechanical engineering and in operations of mission critical facilities.
All right. And Vi, why don't you round us out?
Hi, I'm Vytenis Milunas, usually called Vi Milunas. Marvin and I have similar backgrounds. I am also a mechanical engineer, and I have spent just about my entire career either in the design of HVAC systems or in the maintenance and management of them. I spent a number of years with Marvin at Argonne National Labs. Marvin was on the research photon source side. I was on the basic facilities management side, managing mechanical projects and assisting with the maintenance people there. The last 15 years, I've been with the University of Illinois as the director of physical plant construction, and recently just as we created an engineering and commissioning section to address various issues such as this COVID crisis that has hit us very hard. And I'm very happy to say that Marvin has also been kind enough to join us at the university recently to help us out with these projects.
All right, fantastic. Thank you all. And without any further ado, we'll go ahead and get into our questions. So this first one is for all 3 of you. The question here is, in what ways have you seen COVID change your job responsibilities? So particularly related to this issue of ventilation issue resolution. Anybody feel free to jump in?
Well, in my case, it's been more of a shift on emphasis. Working at Argonne in the programmatic division, we ran a large user facility that brought scientists from all over the world to do research. And so we had very stringent requirements for availability of our machine. So we were constantly in the process of dealing with things on a immediate basis to keep things running. What's changed with COVID is the amount of things that we've had to start relooking at, the quantity and the emphasis on getting it done very, very quickly. So for me, it's been more of a shift in terms of getting away from some of the more operational engineering things and focusing most of my time on these COVID issues and system performance verification.
If I want to go next, I can. I think it is a shift in focus on what issues we have to address, especially from the maintenance side. It's always been very easy to get into the rut of, well, if it's working and people aren't complaining, then there's no reason to really look into it any further. What we have found through the various projects in the last 12 months that we've been involved in is that we need to spend more time and more budget uh, looking at our central equipment and to make sure it's working properly. Um,
Okay, great. And Lou, if you'd like to go next.
Sure. So in a similar manner, I think it's basically increased a lot of the work that we've done, and not as much changed it, but sort of focused on some of the key issues. One in particular is just much more collaboration with other groups around campus, including facilities and design, engineering, repair and maintenance, medical department, faculty, and the general community as well. I think it's also given us a better opportunity to understand some of the problems that facilities faces in maintaining equipment, particularly HVAC systems. So as EHS professionals, typically, not always, but typically we're looking at controlling exposures to chemicals from a fixed source. And the difference here is we're talking about a mobile source, and that's humans. And so whereas in our typical approach, we would look at designing a local exhaust ventilation system, fume hoods, biological safety cabinets, other kinds of local exhaust ventilation. In this case, we can't do that, can't control at the source. So we do have to think about dilution as the control for reducing exposure. And that has forced us to know a lot more about general HVAC systems rather than local exhaust control systems. The other thing I would say is we've certainly had to learn to communicate a little bit better about what we know and what we don't know. We've also had to be more agile. All of us had to be more agile, as you know, if you can think back to February and March, as information comes in, conditions change. We know more about it. So early on, people weren't as concerned about airborne transmission and mostly focused on surface and droplets. And then when that changed, we needed to refocus our efforts to the HVAC systems. So a whole variety of things, I think, resulted in the change, the way we look at our jobs.
Mm-hmm.
Why, did you have something you wanted to add?
Well, I was kind of thinking that Lou's comment made me think back to the first project that we had to attack at the beginning of the virus. Was the College of Dentistry ventilation project, where we were tasked on coming up with solutions on how to bring patients back into a dental school where there were rotating 400 patients a day through the building, and how to space them, get the proper spacing between the stations to allow, getting the 6 foot and even more distances that were recommended by CDC. Looking at what can we do to bring all these patients back in when they sit down to get treated. There is a very large amount of particulate and aerosols that are generated from drilling and cleaning and so forth. So I tell you, it was one of the most interesting and challenging projects, I think, in my career, and Marvin was with us working on that too, coming up with concepts, upgrade, trying to follow CDC guidelines for increased fresh air, for dilution, Hepa filtering the systems, spacing the people further apart. Testing, of course, was a daily testing of all the people coming in, and the
Ionization.
and so forth. And as we went further along, we felt that that wasn't enough. We ended up looking at computational fluid dynamic analysis of aerosols and the ventilation patterns within the cubicles and teaching classrooms where they had 40 to 50 chairs all in one room, all of them possibly emitting aerosols. So then we also decided to add bipolar ionization devices in all the air supply ductwork to additionally mitigate any viruses that could end up being up in the air.
Yeah, that was a good example of collaboration because the School of Engineering staff were engaged, and they did the CFD analysis, and we were dealing with a ballistic condition where the water that's being used in these drilling and other tools, I mean, it is coming out with some momentum. It's got some velocity behind it, and we got into discussions about the nature of ventilation systems is to take room air and mix it. That's part of the process, and if you start generating lots and lots of aerosol particles, then your ventilation system is engaged in helping distribute them all over the space. So, looking at dilution is one thing, but nobody could tell us what the infection dosage was. We didn't have any kind of limits on how much we could have in the air. So the bipolar ionizers were put in as a means of keeping the concentration of active viruses down. Unfortunately, I don't think there's a way to measure that, since we don't have a metric on what's allowed or what the threshold is.
Yeah.
But.
And it did seem to assist in coagulating the particles so that the HEPA filters did a better job of eliminating them as the air flowed through them.
Great. Yeah, I'd like to also hear Lou kind of jump in here as well.
Yeah.
I was wondering what your thoughts here were on air turnover rates and kind of thinking about this element of redistributing air versus cleaning it, filtering it, moving it outside of the space, and then how you sort of look at that.
Yep. So there are, I know there's a couple of folks on the call who know my feelings about air change rates, air changes per hour in general. This is a different situation. So in general, I don't think that is the important factor. I have a colleague who likes to say air change rate or air changes per hour is the answer to the question, is not the question. It's the answer to the question. So you basically look at the hazards, decide what controls you need, local exhaust, you put that in, and then you calculate what the air change rate is. Here, it's a different story because we are talking about dilution. So dilution becomes a little bit more critical with all the uncertainties that both Marvin and Vi have mentioned as well, without really knowing what is the safe level, what are we trying to control to, and that makes it a bit more difficult. The other issue about air change rate is that by itself, it's not enough information. And I think Vi made a reference to this in a bit, and that is really what's the effectiveness of the air change rate. It is how much air is mixing and how well is it mixing. And we don't have a whole lot of good nationally accepted criteria to determine that. ASHRAE and others have been looking at ways to try to characterize this subject, but at this point we don't. There are a number of systems out there and a number of companies out there that can do this, and it will claim to do this in several different ways. And having some information is better than none. But again, it's key, and as I'm sure you've all heard, that some of the earlier cases were caused by air in a restaurant blowing over some ill people into the tables of other people. And so even though there might have been a lot of air coming in, it was blowing directly, contaminating some people from other people. So it's not as simple as getting a number. What's the air change rate per hour that you need? You really have to look at the case-by-case situation.
and I found that, you know, in many cases, people are sort of stuck on that. They're stuck on air change rates and not catching necessarily immediately the nuances of the path in which the air flows. And as you said, in the restaurant, people are sitting downwind of people who are generating viruses. So having large air change rates could, in fact, in some cases, help, you know, move and distribute the viruses through the space and create more of a hazard. Again, that's why we were looking at some way of neutralizing the viruses within the space. And there's problems with that too, because we don't know how quickly the ionized particles actually will deactivate the viruses or make them unable to replicate or cause a contagion. So there's more research that has to be done in that area. And so you're looking at sort of a more hybrid approach to air change rates, air distribution paths, and how you can, in a sense, sanitize the space while people are occupying it without hurting the people themselves.
And an air change rate by itself, as you guys are saying, isn't the answer. And another way of looking at that air change rate, if you want to dilute, you have to bring in outside air. Just recirculating the air, if you increase the air change rate and you're just recirculating the air, you're not really diluting anything. Besides, you may be sending that air into a different space from the space that the contagion is in. So one of our tasks in all of these projects that we've worked on over the last year was to increase the outside air to a point where we felt that we were getting a significant amount of dilution.
The one difference that I would say, though, that needs to be considered is if you're recirculating the air, but you're filtering it. So if it goes through a filtration system that is adequate and is appropriate for what you're trying to filter out, then that can help things a bit more as well. And just the last thing I would say about the air change rate, one thing that worries me is that if people get fixated on an air change rate and think it's safe, then there's sort of this false sense of security. Oh, 6 air changes per hour is what is recommended. I've got 6 air changes per hour. Now I don't have to worry. And that's one of the things that concerns me is not having a good understanding of what that means.
And of course, as we know, occupants in buildings can do many things to adjust and affect how airflow goes. I know there have been a lot of conversations we've had here about the effects of plexiglass screens in places and how that, too much of that may actually be detrimental to the airflow in a location. One of the things it sounds like is a common topic here is just how difficult it is and can be to connect measurements and actual kind of numbers back to effects, that difference between statistical significance and maybe clinical significance. So Marvin, Vi, I was wondering if the two of you had new COVID influence standards for verifying airflow or directionality when bringing a system back online, whether there's anything you're sort of now looking at as a different set of guidelines.
So that's tough. That's a hard question. That opens up a whole discussion. I mean, again, the nature, except in some specific laboratories where you have, or maybe hospital settings like operating rooms where you have a directional airflow type air diffuser, the whole system is designed to mix the room air, basically through induction by having high velocity jets come out of the diffusers. And then we're basically trying to remove heat in the room, which most of it is through convection and induction, and that just creates a problem for spreading the any kind of contaminant that's in the room. They've done a number of computational fluid dynamic analyses for laboratories. If you have a spill, and you can see in some cases having high air change rates or having air distribution patterns that are set up to remove heat can actually enhance the evaporation rate and actually make the situation worse, or spread the contaminant throughout the space more effectively. So I don't think there have been any new standards. I think it's something that's got to be looked at. a distinction has to be made between the type of use of the space, a laboratory space versus a office type space. But now we're bringing contaminants or people who are generating contaminants within an office space. So now the office spaces are sort of turning into more like a laboratory space where you have a potential to have a spill or something escape within the room itself. So that's quite a conundrum, I think, at this point.
I think we have, because of the variety of occupancy types we have on campus, on the 16 million square feet of property that we're trying to maintain, reviewing the CDC guidelines and the ASHRAE recommendations and the standards that ASHRAE puts out, we've seen a lot of data come out of those organizations over the last 12 months. And still, when we look at the different occupancies that we have, one of our first pilot projects was a theater building with 40-foot ceilings, and trying to decide whether we wanted to do 4 or 6 air changes in a space of that volume is a significant challenge in itself when the people are down at this, the occupied level is below 10 feet. I think, Marvin, you had some thoughts on that.
Yeah, I mean, so we're trying to treat the entire, well, again, people got fixated on air changes per hour. And which, again, I agree with Lou, they shouldn't. But if you look at the space, what ASHRAE would consider the conditioned or occupied space versus the entire volume. So where do you apply that air change rate number? What volume do you use? And if we use the entire volume of the space, these numbers get very, very large. So again, I think there has to be some rethinking if we're going to have to design buildings to deal with some of these contagion issues, and look at how we distribute air and how we define ventilation rates in these spaces.
Yeah, absolutely. And so I'm just going to move on from this one real quick. I think keep the questions going here. Lou, the question that I had for you next was wondering, what are some of the most common shortcomings that someone could expect to find during an HVAC audit? I know one of the things that Marvin and Vi have touched upon a little bit here is several of their projects involved really looking at existing spaces and saying, okay, are these actually performing up to task, and what can we do to improve them and get them working properly? So is there anything there that you sort of have on your checklist as a must include?
Well, certainly, I think as they've mentioned, ASHRAE has guidelines on basically getting the systems up to running the way they were designed. And the problems that we've discovered are that we may not even have the original designs to know what they should be operating. In doing an audit, we have found, so I mean we've and got this from other places as well, but we have over 600 air handling units that we've assessed on campus. And they're all types and kinds, so there isn't one size that fits all, because buildings are different ages. They were designed under different codes and standards. What we have found in some cases were the wrong filters in place. The filters were dirty. Systems weren't calibrated as well as they should be calibrated. We have spaces that were not designed for occupancy that are now being occupied, a storeroom that becomes an office. So it didn't have any ventilation to begin with. So you really have to think of a holistic viewpoint when you're looking at the HVAC system. The controls, and I know there are some questions in the chat around, how many people can be in a space based on the ventilation and others. And we really have to think about, and I've seen this someplace, can't remember where, but sort of you've heard referred to as a Swiss cheese model, where we're looking at how do we control exposures. Well, we start at the source, which is us, so we put a mask on them. And then we do the social distancing, then we have some dilution ventilation, we do the cleaning. There's a whole variety of things we do to minimize the risk. In many cases, where one of the major ways to minimize the risk is to hopefully get people who are sick not to come into work. But again, since many may not have symptoms, be symptomatic, that's hard to control as well. But if you're looking at sort of controlling all of those things, and then of course the latest thing in the last number of days that's come out is, might it be effective to wear double masks, or do we eventually want to send everyone to, or as many people as we can, to N95s? So the typical face cloth covering is going to prevent you from exposing others, but putting on an N95 can help to protect you from others. So again, there's a whole variety of approaches that could be made, and the idea is to collaborate with medical and facilities and everybody else I mentioned at the beginning to come up with what worked best for your facility.
You know, it's so funny listening to what was said earlier about just the difficulties of trying to navigate the changing landscape that was February, March, as we were learning new things, new information was coming to light. It seems like we're almost approaching that again, just with a new administration here in the US. Dr. Fauci sort of having more freedom to share the information that's available to him, and also with these new variants coming in and exhibiting different behaviors, whether some of those skills that we picked up earlier in the pandemic in terms of just agility, being able to adapt, kind of update as we know more things might come back into play. Well, our next question here is for you, Marvin. I was wondering, working within constraints can often limit how quickly you can resolve a ventilation issue. What do you do to remain effective in these tense situations?
So basically, coming from the environment at Argonne, a number of things. One of the things is, as Lou alluded to, is documentation. So in all our construction projects, typically at the end of the project, you get a turnover package, which has some operation and maintenance manuals and some other information. What I've done over the years, over the past 3 decades, is maintain a collection of all the original shop drawing submittals. So now we have all the technical data for all the equipment. So if we have a problem and we want to try to diagnose it, we have fan curves, pump curves, control valve, and other instrumentation information that's readily available. And that to me was critical in being able to respond quickly to problems, and we're not running around looking for this information. The second thing is that our engineering and maintenance group worked as a team, and we always engaged maintenance in the design process. So they, I mean, fully engaged them. They were partners in the design of the facilities, and they brought their expertise with equipment and operation. And we also engaged, in the case of APS, the Advanced Photon Source, the lab and scientific and engineering staff. Because a lot of our spaces were the performance of the tool set was dependent on the environment that they were working in. So the third thing we did, and the thing I like to emphasize a lot, and we don't do enough of it in this industry, is recommissioning. So we were trying to establish a regular, ongoing, continuous commissioning program for mission critical systems. And the advantage of that is not only are you making sure that instrumentation is calibrated, that devices are working, that things haven't gone out of whack, that people haven't gone into the controls and overridden or reset things, which is a lot of stuff we found in some of our HVAC audits, or changed even the sequence of operation. It acts as a retraining process or a training process for the maintenance staff, because we engage them as part of the commissioning team. So now they're constantly working and starting, from square one, bringing these systems up, checking the performance, checking that the safeties are working properly. What happens if something trips out? How do you re-engage the system? How do you repair it? Where's the information? Where are these shop drawings that we've been collecting over the years? So those are the 3 things that I guess I would emphasize in helping to be able to quickly respond to a problem with any equipment or any site issues.
Great. And looks like we have just enough time for one more question here. The Q&A is really hopping, so I think that's going to take up plenty of time. So Vi, the last question is for you. I was wondering, how have you kept maintenance staff well trained as your ventilation systems become more complex?
Well, that is probably the biggest challenge that we have as far as, and I think a lot of organizations are in this same boat. Um, we have to continuously have training set up for our maintenance, our what we call our heat, light, and power staff, the operating and especially the operating engineers of the facility. The technology of going from pneumatics to electrical to electronic to direct digital, and then moving even further into predictive maintenance, and it's moving even past that. The control systems are getting significantly more complex. There's so much programming buried behind them that it's in some cases it overwhelms the maintenance staff as far as trying to keep up with what needs to be done. And especially in a public institution, it makes it a bit more challenging where you have to get to the low bidder in most times. And so we have on our campus, I think, 7 different control systems with each one having its own peculiarities and programming requirements and software requirements, and each one needs its own training. I think for us, it's an uphill battle, especially as this gets more complicated. One thing that we try to do is move towards a standardized building automation system that sits on top of everything, our Tritium platform that consolidates all the data to make it easier for the maintenance staff to be able to see all the information that they need to see in one platform instead of having to log into 7 different systems to see what's going on. And we still have pneumatic systems on campus too that are scattered throughout the older buildings on the west side. So all I can say at this point, it's a major challenge to keep it going.
So you think you said that you had 6 different control systems for your
seven.
Have you ever found that, finding the right person who actually knows the system well enough to really help administer it is difficult, or do you sort of have the one person, 7 hats, user you go to for all that stuff?
Well, when I first got here, it was a real big challenge about 15 years ago. You had a couple of people that knew this system, a couple of people that knew that system. We have now a centralized programming group in our IT department that assists all of the operating engineers with the software. So, and they're getting trained on all the various systems that we have on campus. So we have a centralized group that can assist as needed.
All right. Are there any parting thoughts here before we move on to our Q&A? Anything that we'd like to talk about that I haven't touched on yet?
Parting thoughts.
There'll be plenty of time for. Oh, sorry, Marvin, you were going to say?
I said I have a lot of parting thoughts, but I don't think we have enough time to get. They start to get very nuanced.
Well, hopefully there will be some time to really dig into those. It looks like the Q&A is really going right now, so let's get into some of those questions. But before we do, just a quick plug here. I'm going to launch a poll. So these are our community connection webinars. They keep going because members of our health and safety community come forward and are willing to volunteer your time to help keep these running. So like our 3 panelists today, it just helps provide a space where everybody can come and talk about these particular subjects, trade really valuable critical information right now, helping to keep everybody safe. So if you or somebody in your network is interested in being a panelist, we'd love to know. If you'd like to let us know what topics you're interested in seeing. And additionally, we are thinking about starting a new series, just sort of more of a drop-in, come with your questions and then we'll talk through them, sort of like our Q&As here, but a little bit longer format. No real presentation, but just an opportunity to say, hey, I've got this problem that I'd really like to work through, maybe get a few people's opinions on, and try to create more of a space for those conversations to go forwards. As you can see here, we have, I think, 12, maybe 14 questions already, and definitely don't have the time to get through all those. So we'd love to be able to make a space where you all can get those answered by your peers. So while I leave that up, we do have our newest webinar here, Health and Safety After the Vaccine. That one is available in early March. It is going to be talking about Just what some big thinkers are imagining will happen after the vaccine is in place, rolled out, how things will change, how things will be different. Just great to be looking forward and be able to prepare as we can. Take a quick look over at our word cloud, kind of see how everybody's doing. Leave that up for just a little bit while we get started with our Q&A here. So if you haven't yet, go ahead, go over to your Zoom webinar control panel, click on the Q&A button, and it'll pop out the Q&A box where you can answer each other's questions, ask for clarification, thumbs up the questions you like, and ask your own questions. It's a great chance to talk with the rest of the community here. So our top question here is from Suzanne. Suzanne says, thoughts about the safety of conference rooms for safe maskless breaks, lunch, coffee break, etc. If the limit is to one person at a time, what length of time between users do you recommend? So Lou, would you like to weigh in on this one?
Sorry, I was lost my sight there for a second. So I think that, again, it's unfortunately one size does not fit all. I think you have to look at the Swiss cheese model in terms of what you want to, what you want to be able to do, can do. We have, being at a university and many other universities the same way, I have a lot of faculty who dove into this, and we have a couple of faculty in particular who've developed a model, which is kind of what we're using. So we can plug in the size of the room, the ventilation system, and how many people we think can fit in that room based on a number of factors. And the factors, again, are determined by what's the control. Is it an N95 mask as opposed to just a face cloth covering? And the other kinds of factors that are going in, and that's kind of how we determine this. I think probably I'm dancing around and saying that I don't think there's an easy answer to that without really delving into a lot more detail about the space and the activities and the time, et cetera.
Marvin, would you like to weigh in on this one as well?
Well, I agree with Lou. I mean, it really depends on the specifics of the space, what the ventilation system is. Again, I think looking at some of these questions as we've been talking, ventilation systems are again designed to spread things around the room. They're designed to cause air mixing, and in light of that, again, we went back to this air ionization technique. I wish there was more research to look at the effectiveness of it, how long it takes to actually neutralize the viruses, so that we would have more guidance in using that, because that would be an effective way potentially to maintain and lower the concentration of viruses in the room down to a point where the rooms become safer and safer. I think given the way we've designed ventilation systems in most of the existing buildings, we're just moving air through the spaces may in many cases have the opposite effect and could potentially spread things. Obviously, if you're putting one person at a time in the space and then you're flushing the space out, that's one methodology to do it. We've put in standalone fan-powered Hepa filters to increase the filtration rate and try to remove viruses from the air at a quicker rate, which would reduce the time between people coming in and exiting the room. So we need more research, I guess, is what I'm saying.
Yeah. And depending on the air change rate, the length of time to clear the air, there are some calculations available depending on the room volume, and coming up with the time frame to get a feel of when you've got enough dilution in the space between, because we're doing that with classrooms now. We want to make sure we leave the space empty for so much time between classes to give a ventilation, some clearance.
Yeah. The other side of the coin, we looked at the school in terms of the school of dentistry is a lot of these models are assuming near perfect mixing. You could have, parts of the room that are very stagnant, that don't see the effect of the ventilation system mixing air in the space. So again, it's very nuanced. You have to look at each individual space and the nature of the air distribution system.
Yeah, I think on campus, I don't think we've got lunchrooms available for. They're not open for employees at this point. I think if people go, they can have lunch in their offices, or they go outside.
Yeah, tough time to go outside for lunch, though.
Yeah, very.
Yes, in Chicago, yeah.
Just to move on here to our next question, from Hansina, they'd like to know, do you have any thoughts on enclosed stairwells? We have asked folks to not share elevators, but those stairwells are now getting quite a bit of use. And of course, there's that ever-nagging issue of, okay, so you're not sharing an elevator, but having one person go in, go out, and go back in is still not the greatest.
Well, our approach has been to put in these local fan-powered Hepa units, and in some cases you can buy them with bipolar ionizers built in. So you're not only filtering, but you're filling the space with ions that hopefully will neutralize some of the viruses that are being generated. I can't think of anything else you could do.
I guess the other thing that I'm probably repeating myself, but that we really have to look at what's the risk with that. And again, the amount of contact, I mean, in the stairwell, unless people are stopping and talking to each other, is pretty minimal. And if they're, again, wearing masks and there is some ventilation, I think that the risk there would be pretty low.
Yeah, because a lot of people want the ventilation system to be the answer for their problems, but the key issues are masks and separation.
Yes.
Distance and time, contact time.
For anybody,
I think in a number of our buildings, we've also, gone to making stairwells one way, either up or down. So again, you minimize the potential contact.
All right, moving on to our next question here from Joan. Joan would like to know, are there concerns for maintenance staff changing filters? And if so, what level of PPE is recommended? Specifically, she was wondering about N95 masks. So is that an area that you all are looking at in terms of outfitting your maintenance staff to actually change the filters that we've been talking about?
It was discussed. Yeah, I don't know if they set up protocols for that,
I know we had the last conversations we had was that N95s were a minimum for handling the HEPA filter replacements. Of course, gloves and so forth, but yeah, I can't give a firm answer on that one.
That's probably what I would do as well.
I mean, the other thing you'd want to do is just bag them and leave them sit for a long enough time where the virus is becoming active. Other than that, I can.
Before we move a little too far away from this subject of ionizing HEPA filters, there was a follow-up question by Michael asking if there's any concern that the ionizers generate reactive radicals that might irritate eyes and respiratory system.
No, that's been looked at pretty carefully. I mean, this is not a technology that's, a month or two old. This has been around, gosh, I'm thinking 5 to 10 years now. The discharge on the electrodes is set so that they're not generating ozone in any noticeable quantities. And I think there's enough literature out there and enough testing that we're pretty confident that there shouldn't be any problems.
Yeah, these aren't your residential type of ozone generators for decontaminating. These are bipolar devices that are safe.
Great. Moving on.
One thing mentioning about filters and replacing filters, one thing that we had talked about in specific cases was adding UVC disinfecting lamps in the air handlers. They've been in many times in the past used for cleaning keeping your coil, your cooling coils clean of mold and mildew and so forth. But they're also very good and effective in killing bacteria and viruses in the airstream as long as your kill time is long enough. And they can also then at the same time, if they're on near the filters themselves, they can keep the filters in good shape.
Great. Well, moving on to our next question here, a little bit more of a broad topic. And before I say this one, I'd like to just go ahead and preface this by saying one of the things that I love about these webinars is that our panelists don't always have all the answers, right? There are lots of fantastic questions that deserve answers that just might not be in the wheelhouse of the people here. So that's where we go to you, our audience, to go and jump in, talk about your experiences, share what's worked for you and what you've discussed. It just is really helpful to help spread that information that doesn't just live in silos and kind of die in each of our different organizations. So the next question here is from Vernada. Vernada would like to know, are your facilities establishing specific protocols for managing the ventilation of spaces where COVID positive individuals have worked?
I don't have an answer. You know, Vi, I really.
I don't believe, I know if there has been a positive individual, these spaces are decontaminated and the systems are cleaned. But when you say managing the ventilation, I'm not quite sure what, I mean, there's not much you can change in the air handler itself, but the spaces are ventilated and cleaned and disinfected, you know, the surfaces and so forth.
Lou, did you have anything?
That's the same here. I mean, because we don't think at this point that there's any concern about contaminating the ventilation systems from someone who's tested positive inside the space.
Great, thank you. And if anybody wants to go ahead and continue talking about some of these answered questions, you can hop over to the answered Q&A tab and continue that conversation. It looks like there are still some great conversations going over there, so I definitely recommend checking that out. Next question is from, I'm gonna hopefully pronounce his name right, Malachi, and asking, what is your opinion on the efficacy of increased filtration efficiency and single pass air in relation to reducing COVID-19 potential for transmission and actual measured performance?
Well, I think with filtration, one of the problems we've seen is that the filters are not put in properly, or filters are missing or damaged. If you're dealing with Hepa filters, typically you have to ensure that there's in some cases a gel sealed so that they're sealed properly and that you get the air to pass through the filter so you get proper filtration and there's no bypass. But measured performance, I don't have any data on that at all.
So I guess the way I'm reading this is the question is it better to increase the efficiency of filtration or to just have single pass, which means not returning it back to the room.
So of course the single, if that's the question, single pass of course it gives you the highest dilution rate and there's no recirculation of the air.
You don't have to worry about the filters.
Then you don't, it doesn't matter what kind of filters you have.
Oh, there you go. Great, moving on to a slightly higher level question here. Stephen would like to know, should ASHRAE revisit its outdoor air standards in light of infection control since future pandemics are likely? I don't know if I can speak to the likelihood of future pandemics, although certainly I think we're all.
I don't think it's really an issue of the outdoor air standards. I think it's really an issue of filtration and air distribution. To be honest, again, these office spaces now are spaces that are, or conference spaces that have people in there who are potential sources of a contaminant. And the way those spaces are designed, they're designed to just spread it everywhere before it goes back into the ventilation system. So that's where I think some of the research needs to be focused.
And recently, ASHRAE has been changing the, given the energy conservation efforts that ASHRAE has been involved in, the amount of fresh air that is being designed in current standards compared to 20 some years ago is significantly less. And you've got the demand control ventilation systems that are included, that if the CO2 level is low enough, you're going to bring in even less fresh air. So I think those types of systems will have to be reevaluated, because we have basically disabled every demand control ventilation system on campus, and we're maximizing the amount of fresh air we can bring in without damaging the equipment or freezing coils.
I think what you will see, and I think we're already starting to see some of this now anyways, is certainly for new facilities or renovated facilities, and maybe even going back to the older facilities, looking at designing in more flexibility so that in the event of a pandemic or some similar event, you can switch systems to operate with more outside air than you now can. Because as we probably all know, I mean, there are, even though the ideal case is to have a certain amount of outside air and MERV 13 filters, some existing systems may not be able to operate at those levels. So they're basically stuck at doing that. And the idea would be to be able to design facilities to be much more flexible. And you probably see that beyond the HVAC systems, certainly in the ability to isolate rooms and even in what it's going to do to the future design of the way we operate our universities anyways.
Yeah, a lot of things are going to be changing, and for better or for worse, probably permanently here. It's I think going to be hard to let go of the impacts that COVID has had even many years down the line, when hopefully it's no longer really something that's actively affecting our lives.
And I think ASHRAE as an organization is always revisiting the standards and guidelines. I mean, there are committees that are constantly looking at where we are and where we should be going forward. So I'm sure there will be some significant discussions going on now.
Okay. Moving on to our next question here. We have one from Denise asking, have you had to address the ventilation design for data centers, which have recirculated air with MERV 8 or less filters and have limited OSA with the risk of COVID-19 transmission when occupied by staff? So have data centers fallen into any of your job responsibilities?
Well, we have spaces where we have, as Lou alluded to, that are older spaces where you don't have a lot of ventilation to begin with. So it'd be very similar to what you're seeing in a data center. The way I've approached this to put, again, local fan filter units in, freestanding units to increase the circulation of air that's been filtered and is now considered clean with respect to virus loading. So that's the only thing I can really think of doing.
Yeah, we've ended up from our studies, we've ended up purchasing several hundred HEPA filter portable HEPA filtered units that we're putting into the classrooms to improve the filtration rate for spaces that are old and don't have the capability of improved ventilation.
Yeah, we're scheduled to do some particulate counts in these rooms and compare them to other spaces to see how effective the local HEPA filters are. We haven't done that quite yet, but we're on the verge of doing that.
Well,
this might also be an area that has some potential to use UV treatment as well, depending on the population in the space.
Yeah.
Fantastic. Well, somehow, oh, Marv, you were going to say something?
No, I was going to say UV is a good potential, especially for an underfloor system. You could put UV lights under the floor and sterilize the air that's being brought up to cool the servers. So, yeah, that's another alternative.
Somehow an hour has flown by here,
Mhm.
and we still have a good number of questions here, and this is the point where we'll usually give our panelists the permission they need to leave if they have something else that needs to get taken care of, or if something's come up in the meantime. We will hopefully keep going for another 15 minutes or so, or until all of the questions have been addressed. But really a huge thank you to our panelists for spending all this time to get prepared for this, sharing their answers, and for speaking and just coming on and taking time out of their schedules for this. So this is the, if any of you need to leave right now, by all means, feel free. But otherwise, we will just keep on going with the questions as they are here for us.
You can stay for a little bit.
Yeah.
All right, great. And of course, you are welcome to participate in our check-in. Let us know how you're doing, kind of how you're feeling at the little peak of winter here that we are in the middle of. And yeah, I love this, rolling up my sleeves, wary, motivated, overwhelmed, stressed, festive, hungry for information, but hopeful. The next question here is from Chris. Chris would like to know, if you don't know what particle density you need to achieve through dilution, what framework do you use? And he asks about ALARA.
I'm familiar with ALARA, but we don't have a friend. I mean, we don't know. I mean, that's the big question. What is the threshold in terms of viruses per cubic volume of space? I don't know.
Yeah, that's definitely the problem. Is at this point not having that kind of data to determine what's the concentration that you want to reduce down to.
Yeah. So at this point, it's the best that your system can do.
Right.
And that's why in spaces where we don't have the capabilities of increasing the dilution rate, we have fallen, the backup is to add local filtration units to assist in attempting to clean the air. But again, even in these spaces, the students have to wear masks. There are seats that are closed off that they're not allowed to sit. They're so many feet apart. And we have reduced occupancies also that are, we've got signage up that these classrooms can only have so many occupants in at a time, and it's typically half of what ASHRAE has been recommending for a typical classroom occupancy. So there's a lot of different steps that have to be taken here.
I think I would just emphasize what Vi said, that we all have to be careful not to, get narrow vision and focus in on the ventilation system and think it's the be all end all. And we have to remember this is we have to take a holistic view, and there are a variety of ways to control the exposure.
The wearing of masks has to become some sort of fashionable trend in society.
Yeah, a lot of organizations are offering branded masks that are great, kind of using that in a lot of things. I think it'll be interesting already seeing the inauguration, just the impact of seeing everybody wearing a mask and being socially distant was much greater than I was expecting it to be, for myself at least.
We need to have masks with LED lights, and you can just do make statements with your masks. Just get money for advertising or something.
Also, you got a little Pepsi thing, the
Pepsi logo.
Pepsi logo on your that glows.
Mask sponsorship. Quick plug for our upcoming webinar in a few weeks is we're going to be talking about fit testing, discussing how to actually get a respirator properly fitted to a face. And also, I think we've all seen those people who hear, okay, double mask, and then they put a regular face covering on and then put a respirator over that. And just hoping to spread more information in addition to just really navigating the difficulties of being in close contact with somebody who's necessarily breathing out unfiltered air in your vicinity. Going up next, we have a question here from Laurel. Laurel asks, there is a great emphasis on sustainable design for ventilation in buildings, both lab and office. The goals of sustainability focus on lower air changes, but with COVID, it seems that more air is desirable. And Laurel is wondering what your thoughts were on that tension between those two principles.
Well, depending upon what climate zone you're in, it's usually the amount of outdoor air that you're bringing into a space that dominates in terms of energy consumption. The actual moving of the air doesn't necessarily, it can be, but it can often be overstated as what proportion of the overall energy profile the building is using. So I'm not so, going back to what Lou said, I think we get hung up on this air change rate issue as far as mitigating COVID contagious events, but
I mean, we can still have energy conservation even if we have increased air changes.
yeah.
I mean, a research laboratory, a chemistry laboratory has 100% once through air, but we can put in run-around heat recovery coils to recapture the energy lost to be able to still stay sustainable. So it's a balance. It's a balance between the two.
I mean, we could get really into the nuances here. I've studied chilled beam buildings and looked at the energy consumption of the fan system versus like a standard variable air volume. And sometimes it depends what metric you're using. If you look at the energy per CFM that's consumed moving the air, a lot of the VAV systems, even when they're running at high outputs, can be more energy efficient on that basis. So it's kind of it's a more complex question than simply air change rates.
I would just add two things to that. There is a difference between lab and office ventilation, which I think we're alluding to. And lab ventilation, probably for COVID, the need to increasing the air change rates in the labs is probably minimal. The second is that, again, as I mentioned earlier, we're probably going to see designs for being more flexible, because hopefully we're not always going to be suffering through a pandemic. And so we'll have running those conditions, and then maybe every 10 years or whenever it is, we may have to change our mode of operation.
Mm-hmm.
Hopefully it's every 100 years.
I'd really be fine with not living through another pandemic in our lifetime. Right. Next question up is from Neil, asking, how do you determine that a bipolar ionization unit is actually working? Neil says he's done particle counts upstream and downstream and found that the unit actually had no effect.
No, it's not. So they can measure the ionization level in the spaces. So when you design it, they will design to a certain part per million ionization level in the space, and then they'll go in there and they'll actually physically measure it. And in most of the applications we've had, I think we've always exceeded the initial design. They've been very conservative in the installation.
Yeah. And I don't know if it's a particle count that's looking at the ions are the ones that are,
Right.
I mean, I wouldn't call those particles at this point. They're smaller than particles. It's
the ionization,
yeah.
some of them can agglomerate particles.
Yeah.
So you might see an increase in the number of larger particles when you do your particle count. But
yeah, we've read a number of studies that a few of the manufacturers have done in a laboratory setting, where they have shown a reduction in bacteria and viruses.
Yeah, I don't think the bipolar ionizers are designed specifically to agglomerate or to consolidate particles as much. So you might see an increase in larger particles and a decrease in smaller ones. So the particle counter, I don't know.
Mm-hmm.
But the best way to measure its effectiveness is to measure the level of ionization that's taking place in the space.
All right. Moving on to our next question here. These just keep on coming. So thank you everybody for participating. Next one is from Falan. I hope I pronounced your name right. Has anyone had any experience using new microbial technologies? I have a Granger rep for our university that just sent me info on this for our HVAC systems, and they were curious about your thoughts.
I wonder if you could be a little more specific.
Yeah, I haven't heard about that one either. So
Yeah.
is that ringing a bell for you at all? Or is that something that could use some more details?
Microbial.
You-
Could that be about surfaces, antimicrobial surfaces possibly, or coatings? That,
We'll leave that up. Let
yeah.
anybody else weigh in who is familiar with that technology, or if the asker would like to provide any more details, and move on here. There are a few questions asking about using CO2 measurements as an additional safety measure from Suzanne as well as Ellen.
Well, I mean, you can use CO2 as a proxy for figuring out how many people are in a space. I'm not sure.
Yeah, it's only related. You need to have people to generate CO2. So if you go into space and measure low CO2, it doesn't mean the ventilation is any better or worse than it was.
I mean, if you have a demand control ventilation system in place, and it's determining how much fresh air to bring in based on the CO2 levels, it might be it could be to your detriment that the outside air level goes up after the people had already shown up instead of before.
Well, we've installed the CO2 sensors in the outdoor air intake to get a baseline for the ambient, and then compared it to what's going on in the rooms. And yet, as people come in, you can see the CO2 levels rising. I guess if you see them rising beyond whatever the limit that you've established is, you can get a sense that you're not ventilating the room properly, or that you've overoccupied the space and there's too many people in there. I don't know.
So jumping on down to a later question here. This one here is from Stacy asking, is there a way to use directional airflow in rooms rather than optimizing for air mixing for general HVAC redesigns?
Under specific conditions or applications, yes. Yeah. For instance, in the School of Dentistry, the one thought was to occupy one row, have directional airflow so that the air was being directed towards an unoccupied space and sent back to the air handling system for filtration. So I guess that would be one.
Yeah, and in the theater, remember the theater project?
Yeah, we looked at that too. That's right.
We had the large class, the large sort of a theater classroom performing arts center, where you had the air flowing away from the singers and into an empty spot of the room where it was returned back to the central system.
Yes, right. I remember. So in that application, we had unidirectional airflow so that the air at the stage was going towards the back of the stage, and the air at the audience in certain parts of the auditorium were moving back towards the back part of the auditorium.
Lou, is this something that you've been looking at or considering as a solution when you're trying to consider places to redesign or that might require that?
It would in some applications. Again, what we're talking about is what is the source. So if the source is fixed, like performers on stage, then you can look at directional airflow, or if it's fixed in hospitals as it is with a patient in a bed, you can look at getting the flow flowing over the patient and out of the room and not mixing in the room. But in other areas where you have the source people moving around, like in offices or in laboratories, then that's going to be difficult to think of how to use directional airflow.
Yeah, you have that case of the restaurant in South Korea, for example, that where the directional airflow probably contributed to the spread of COVID.
Correct.
Yep.
Right.
Especially with these new, more highly contagious strains that could really be introducing a new risk that isn't necessary.
Right.
Yeah, just in a local restaurant that I've seen, the gigantic tent where they've decided that the city has said it's safe to put like 20 tables in this gigantic tent, and it's outdoors and it's safe to use. There were these gas-fired makeup air units blowing air from one side, and the exhaust was over at the other side, over at the other end. So all of the airflow was traveling from one set of tables onto the next table and onto the next table. till it was exhausted out the other side. So, you know, I found that a little
So that
unnerving.
would, but that would be an example where directional airflow would work if you set it up differently, like a clean room where you have the air coming from the ceiling down to the floor.
Yes.
So it could work in that kind of
Yeah.
a situation as well.
Yeah, and
Again, it
displacement
depends.
ventilation systems may become more, more prominent because of this.
Yeah, the literacy might increase. I've seen this in a few different places that from COVID, risk literacy and literacy around certain topics like respirators and ventilation has really increased quite dramatically.
Yeah.
And people are just accepting that into their daily lives. And, you know, we as safety professionals have a really fantastic opportunity to come in as thought leaders and guiders and, you know, just advisors as people try to understand this world that we've been inhabiting for so long. Well, we are at 4:15 Eastern time here. There are a few questions left that we unfortunately have not had time to. So Stephen, Jairo, Madi, I'm sorry that we didn't get a chance to hear your questions here, but hopefully we'll be able to get to those in another situation in these sessions we've been thinking about. So a huge thank you to everybody who stuck with us, and also, of course, to our panelists for lending their time. I'm gonna go ahead and take one quick look at our word cloud before we close out and get a sense of how everybody's feeling. And I'm sure that if we unmuted everybody, there would just be quite a bit of applause. And we've already had plenty of thanks in the chat here for our panelists dedicating their time and energy to help this conversation happen. So again.
Well, Matt, thank you for having us. It was a pleasure. I hope it was beneficial.
Oh, yeah, absolutely. I think we've already seen from a few people how much this has helped them. So
Good.
Thank you all for
good
lending
meeting
your
you.
energy.
Thank you all.
Hey, thank you all. Take care.
Have a great day.
You too.